Greetings, my fellow software test engineers. Welcome to the Software Test Automation Revealed YouTube channel, or S.T.A.R for short, hosted by me, Cody Gibson. What's this channel about? Well, I'm going to give you weekly video uploads describing what I think are best practices of test automation with a strong emphasis on UI and browser-based testing, which can be pretty difficult. I'll also be giving you code samples, and I'll post those code samples on GitHub so you can download them, study them, and take advantage of them. We'll also study how you can use a database for your test data input to drive your test, as well as storing your test results. We'll have a good look at Selenium-based tests. For those who don't know, Selenium is a coding library which you can use for browser-based testing. It will literally drive the browser for you. We'll also have a look at what I think are best practices in test coding. We'll also demonstrate how to set up a Selenium grid. With the right amount of computing power, you can have a Selenium grid which is capable of running hundreds of browser-based tests in parallel. We'll also have a look at third-party testing tools such as Sauce Labs and BrowserStack and more. And that's going to be just the beginning of this YouTube channel. In episode 1, we're going to be laying the foundation, and I'm going to introduce to you what I call fluent style test coding. Now, this fluent style test coding can be used to greatly improve your productivity as well as reduce your test maintenance. The fluent style test coding uses what I call a model action controller architecture. This is similar to the MVC architecture of a web application. But the MAC architecture in software projects greatly improves your test productivity and significantly reduces your test maintenance. As part of that, I'll be introducing to you what is called the page object model, which is really needed for web application testing. And we'll demonstrate our first Selenium-based test for driving browsers. Then in episode 2, I will introduce the concept of what's called global test data cache. You need this in order to be able to scrape data from one web page and then be able to use it later in another web page for input or validations. After that, next episode, I will introduce what I call fluent style assertions. Now, fluent style assertions are a way of writing validations such that they are easy to read, easy to understand, more or less natural, almost natural language. I'll also demonstrate how you can extend those, make your own custom fluent assertions. In episode 4, I will introduce logging for your test execution. I'll demonstrate how to magically add test logging to your tests such that you have automatic test logging without having to think about it. You don't have to sprinkle your test code with a bunch of explicit log calls. After that, we go to episode 5, in which I will demonstrate how to integrate the database with your test code so you can fetch your test input data from your database efficiently and accurately and in a way that is easily consumable by your test code. In episode 6, we'll be expanding upon that and talk about storing your test results in the database. It's important to store your test results in such a way that they can be easily consumed and used by test reports. You want to be able to aggregate your test results into high-level test reports. In episode 7, we'll demonstrate how to run tests in parallel. It's very important to make sure that your tests are thread safe so you can run multiple tests in parallel. You want to be able to scale up to be able to run thousands of tests in parallel with enough computing power. Then in episode 8, we'll move on and I'll demonstrate how to set up a Selenium grid. A Selenium grid provides you a very, very large set of browsers so you can run hundreds of browser-based tests in parallel. And then in episode 9, we'll demonstrate how you can run Selenium tests through Sauce Labs. Now, Sauce Labs is a third-party service that offers the equivalent of a massive Selenium grid. So instead of just running hundreds of browser-based tests, you can run thousands of browser-based tests. And the cool thing about Sauce Labs is they provide a huge combination of browsers and operating systems. Now, if you would, please click that like button and subscribe so you can be notified when episode 1 becomes available in about a week. So who am I and why should you listen to me? Well, let me go over my early career. I was literally repairing televisions while in high school. Now, the televisions then were not flat panel, they weren't complicated. Most of them didn't even have transistors. The transistor had just been invented a few years earlier, and they were just being introduced into televisions at the time. Most televisions were using vacuum tubes, and that's what these long cylinder things are in here. The vacuum tubes acted like a transistor. Though nowhere near as efficient as a transistor, they actually needed time to heat up in order to operate. So your picture tube, this is your picture tube, is also a vacuum tube. Most electronics were based on vacuum tubes. That's how it worked. From there, I moved on and I began doing assembly language programming in what's called a general automation computer. A general automation computer is considered a mini computer, although, of course, nowhere near as powerful as the computers we have today. Its memory would use what's called a magnetic memory board. This is a picture of a magnetic memory board. It would hold 16 kilobytes of memory. The one cool thing about a magnetic memory board is that it didn't need power to maintain its memory contents. You could literally power down your computer, unplug this memory board, plug it back in, turn your computer back on, and it would maintain the same memory contents as when it was powered off. From there, I moved on and I began programming on a PDP-1123. I was programming in Fortran. The neat thing about a PDP-1123 is that it added a hard disk drive. This is an actual hard disk pack. It holds 10 megabytes. You plug it into this drawer right here. So you'd pull out this drawer, put in your hard disk cartridge, push the drawer back in, hit a couple buttons to spin it up, and then your computer could access it. From there, I made the jump back into hardware. I became an electronic technician for Lawrence Medical Systems. I was working on their assembly line. It was my job to test the brand new units that came off the assembly line to make sure that they were functioning perfectly and they were functioning to the very tight specification required for the medical field. At this time, the personal computer began to be very, very popular. It was like all the rage at this time. You had your Apple II, the Apple IIe, Texas Instrument had its TI-99, you had the Commodore, followed by the Commodore 64, and even Radio Shack with its TRS-80. Now, most of these computers were very, very simple by today's standard, but you could at least run programs on it, do simple things like word processing, some spreadsheets, data analysis, not complicated data analysis, but simple data analysis. That's when I became an embedded systems engineer, as well as the first employee for Attachmate. I literally designed this card, which would plug into the original, this is the original IBM PC, which is then later replaced by the IBM PS2, and I designed this card, which went into the IBM PS2. This card is called a 3270 terminal emulator. It would replace an IBM terminal, which was meant to attach to an IBM mainframe. So the idea is to marry the two together, so you have the best of both worlds. Now, your IBM mainframe is primarily used in financial institutions, such as banks, and maybe even your some stock trading companies and so forth. It would hook up to the mainframe via this coax connection. This coax connection would carry commands and data meant for the terminal. Now, this terminal was simply text only. It was literally 24 rows by 80 columns. And on that coax connection, it had commands to say, hey, set the cursor to this location, and then display this text at that location. So it was actually, for its time, it was actually a fairly smart terminal. Looking at these boards, I actually designed this chip. This is a custom microprocessor chip. Nowhere near as advanced as today's microprocessors, but I actually designed. It's the same chip used here as well as here. And I even still have a couple of them here. So if you can see, this is one of those chips that would plug into that board. And on the inside of it, if you ever wonder what's inside of one of them, well, we actually tore one open in order to try to figure out what was wrong with it. So inside of it, you can see that little metal square. That's all the tiny, tiny transistors used in the custom chip. All right, after that, I became a C software engineer for Wall Data. Wall Data is also a 3270 terminal emulator type of company. trying to marry the best of both worlds, getting the IBM mainframe and the PC talking to each other so you can pull data together and write your reports by extracting data out of your mainframe and putting it into your word processing reports or spreadsheets or whatever you need. After that, I became a C++ software engineer, also known as object-oriented engineer at Intermec. Intermec is a barcode scanner and barcode printer company. That was their main purpose in life, was to manufacture this hardware. The software I would write would marry those two. It would be used for data acquisition as well as making it easier to print the barcodes on the barcode printer. After that, I became a software test engineer at Microsoft. I spent a year testing all of the features and functionality for SQL Server 2008 before it was released. And then I spent another year testing the installation for Windows 7 before it was released. I had to test all of the possible combinations of installation, including installing for multiple languages. After that, I became manager of customer support, also known as technical support, for Art of Test. It was originally called Art of Test, but then it was bought out by Telerik and renamed itself Telerik. And even later, a few years later, it was bought out by Progress Software, and it's still owned by Progress Software today. The product I was in charge of helping our customers with was called Telerik Test Studio. Now, this product was a very interesting product because it would literally hook into the browser and it would record anything and everything you do in the browser. It would record all your keystrokes, it would record all of your clicks, all of your selects, all of the drop downs. Then, once you had your recording the way you wanted it, you can go back into the script, the recorded test script, and add validations to it. So you can do things like verify some text on the field, verify the numbers, and so forth. After that, I moved on, and this is where I'm at today. I'm a senior software architect at Dell. I work on the Premier website, testing it. The Premier website is what we use, what we let our VIP customers use to order product. Our VIP customers are those that are ordering hundreds or thousands of units, and they need it customized to meet their business needs. Perhaps they need a custom logo, or they need a custom install image to meet their business needs. Thanks for sticking with me to the end of my presentation. For your reward for hanging around so long, here's a cute picture of a starfish. And once again, remember, click that like and subscribe button so you can be notified when episode 1 is released. Thanks for tuning in, and I look forward to seeing you in episode number 1.